So the rest of this section will be spent on various attributes of the graphs of rational functions, okay? So we're going to take a look in example 2 at the most basic rational function there is and examine its graph. Okay, so in example 2, it says make a table of values. That's what we do when we don't know what something looks like, and use it to sketch the graph of f of x is equal to 1 over x. State the domain and range of f. Okay, so f of x is equal to 1 over x is the most basic rational function there is. Okay, so think back to how we make a table of values. We are always in charge of x, and then we pick the x values, and then we take each x value and we plug it into the function to get our y value. Okay, and then that will give us a point to plot, and then we plot our points and see what the graph looks like. All right, so the first thing I am going to pick, okay, is going to be 0. Okay, so what happens when I plug in x equals 0? Well, I'm going to get 1 over 0. Okay, you can't divide by 0. Okay, this is bad, bad, bad. So this is actually undefined. Okay, so at x equals 0, there is no output. Okay, so what's going to happen to the graph here? Okay, here is where, if you see where my cursor is, here's where x equals 0. Okay, I am going to put a red dotted line. Okay, this is not an output. Okay, this is just indicating that there is no output here. Okay, all right, no output at x equals 0. Okay, so now I'm going to pick some other x values. Okay, I'm going to go 1 and -1. All right, so if I plug in +1, I'm going to get 1 over 1. That's just 1. So the graph will go through the point 1, 1. Okay, if I plug in -1 for x, this is going to give me 1 over -1. That's going to be -1. So the graph will go through the point -1, -1. Okay, so let's plot these points. So here's 1, 1. Here's -1, -1. Okay, we need more points. Okay, we still can't really tell what this looks like. Okay, all right, so let me go a little further out. I'm going to do 2 and -2. Okay, so if I plug in 2, I'm going to get 1 over 2, so that's going to be 0.5. So we're going to plot the point 2, 0.5. Okay, so that's going to be right, this thing keeps zooming uncontrollably. I'm sorry. So we're going to plot the point 2, 0.5. So here's where x equals 2. 0.5 is going to be halfway between 0 and 1. Okay, so right there. And then if I do the same thing and I plug in -2 this time, it will work similarly. Okay, so let's go up here and do that. So this is going to be 1 over -2. Okay, that's going to be -0.5. So the graph will go through the point -2, -0.5. Okay, so let's go plot that point. Okay, so here's where x is -2. -0.5 is going to be halfway between 0 and -1 on the y-axis. Okay, all right, so we need some more points. Okay, still kind of like, what does this look like? All right, I'm going to pick a weird x value just because I know what this graph looks like. I'm going to pick x equals 1/2 and -1/2. Okay, so if you plug in +1/2, it's going to be 1 over 1/2. So what this is going to be, if you do 1 over a fraction, it flips the fraction. So 1 over 1/2 is going to flip the fraction to 2 over 1, which is 2. So it will go through the point 1/2 and +2. Okay. Similarly, if we plug in -1/2, it's going to be 1 over -1/2. Okay, 1 over a fraction flips it. It will flip from -1/2, -1 over 2 to -2 over 1. Okay, so another point on the graph is going to be -1/2, -2. Okay, so if we plot these points, okay, so I see 1/2. Okay, 1/2 on the x-axis is halfway between 0 and 1, and then the y value is going to be 2. That's this point. Okay, and then if x is -1/2, that's halfway between 0 and -1. The y value is -2, so that's going to be right here. Okay, so what ends up happening if you were to keep plotting more points, okay, if we connect the dots on this side, okay, it's going to look like that. But as we plug in positive x values that are bigger and bigger and bigger, the graph's going to get closer and closer to the x-axis but never touch it. And then in this direction, it's going to get closer and closer to this red dotted line but never touch it. Okay, so it's going to go up like that forever. So that's one piece of the graph. And then the other, it's symmetric over the origin. So basically in the third quadrant, we're going to connect the dots, okay? In this direction, the graph's going to get closer and closer to the red dotted line. And in this direction, it's going to get closer and closer to to the negative x-axis, but never cross or touch it. All right, so this is what the graph of 1 over x looks like, okay? You see breaks in the graph. This is not a continuous function, and the reason for that is because we have a break at x equals 0. X equals 0 has no output, and that causes a break in the graph, okay? This red dotted line that I've put on here, it is called a vertical asymptote, which is a vertical line that your graph gets closer and closer to, but never crosses or touches. Okay, now if you notice, there's a similar thing going on with the x-axis. Okay, I'm gonna put it in a dotted green line. Okay, so hopefully you can see that. Okay, the x-axis, okay, the graph is also getting closer and closer to it, but never crossing or touching it. Okay, so the x-axis is a horizontal asymptote, which is a horizontal line that the graph gets closer and closer to. Okay, all right, so that's the x-axis. Okay, the y-axis is the vertical asymptote. Okay, we will talk about this in a few minutes. Vertical asymptotes, your graph's going to get closer and closer to, but it never crosses or touches. With horizontal asymptotes, usually you won't cross or touch that horizontal line, but it is possible that you cross or touch it. It is possible to cross or touch a horizontal asymptote. You absolutely cannot cross or touch a vertical one. Okay, but we'll talk more about that in a little bit. Okay, all right. So the point is, we're going to look at various graphs of rational functions, and you're going to see horizontal and vertical asymptotes in their graphs. Okay, so even the most basic of rational functions has these. Okay, last thing before we go on to the next example, let's go ahead and state the domain and the range of this particular function, because the asymptotes might make it a little tricky here. Okay, domain you should be able to get from the formula. Okay, the formula is your best bet. Okay, so this is a rational function. You have to find the bad spot. So if you look at the bottom, set the bottom equal to 0. Okay, and solve. Well, you don't have to solve anything. 0 is your bad spot. Okay, you can look at it and eyeball it. Okay, you cannot do 1 over 0. Okay, so the domain here is going to be all real numbers except for 0. Okay, if you need to draw out your number line to write that down, then do so. Okay, if you look at your graph, okay, I'm going to make my cursor big here and you can follow it. Okay, if you go from left or right to do the domain, okay, remember your graph's going to be way out here. Okay, you get stopped along the x-axis at the red dotted line because x equals 0 has no output. Okay, but everywhere else along the x-axis your graph exists. Okay, range you have to get from the picture. Okay, so you're going to travel from the bottom of the graph to the top of the graph. Okay, so if we go from the bottom of the graph, remember the graph is going to be way down here. Okay, so we're coming from negative infinity and we're traveling along the graph. We get stopped at the green dotted line. Okay, the green dotted line is the x-axis. That corresponds to y equals 0. Okay, there is no output there's no y value of 0 on this graph. That's what the green dotted line is telling us. Okay, as soon as we cross over the green dotted line, then we pick up on the portion of the graph that's in quadrant 1, and then we have a graph for the rest of our travel along the y-axis. Okay, so here for the range, it's the same as the domain. Okay, we can't have a y value of 0. Okay. All right, so what we're going to do now is we're going to take a look at some other rational functions and explore their graphs. Expect to see asymptotes.